So now, as we have already seen that what is the body of knowledge for an API 570 authorized piping inspector examination, we have also seen that what is the weightage of different codes and standards in API 570 examination. We already know that there is going to be an open book examination, there is going to be a closed book examination. Obviously, open book examination is a bit more tedious. Generally, it takes about like 3 to 4 minutes to solve a single questions. But API 570 closed book examination is pretty straightforward. Generally, if you know the answer, it is only going to take you 5 to 6 seconds to solve it. If you don't know the answer, then obviously you don't know the answer because there is nothing to reference. Okay, but while looking at the weightage, we have seen that the most weightage for the examination, that is almost 40 to 50% of the weightage of both the examination combined, closed book and open book, is going to be from the API 570 code. So let's look at API 570 code and let's see how the code is written, what are the things that we need to understand about the code, and we'll go further. So this is the first video for API 570 code. API 570 is piping inspection code in service inspection, rating, repair and alteration of the piping systems. Okay, so this is the first video. There are also going to be subsequent videos, so look at that as well. But today, for the first video, we'll just see the scope, reference, definitions, owner, user, organizations. We'll look at all of these things, and then in the next video, we'll go a bit deeper into the code. Okay, so this code, API 570 code, is divided into 9 sections. Okay, the first section is going to be the scope. Second section is references, the references which this documents use to lay down its requirements. Third is terms and definition, acronym and abbreviations. 4 is owner user organization. 5 is inspection and pressure testing practices. 6 is interval and frequency and extent of examination. 7 is data evaluation, analysis and recording. 8 is repairs, alteration and re-rating of the piping system. And 9 is inspection of buried piping. So these are the 9 sections that are laid down in API 570. Also, there are 4 appendixes. Okay, so you have appendix or annex. So you have Annex A, which is inspector certification. Annex B is request for interpretation. Annex C is example of repairs. And Annex D is 2 examples of calculation of maximum allowable working pressure, illustrating the use of corrosion half-life concept. So we'll look at each and everything because 100% of this document is to be known because it carries the most weightage of the examination. So we'll look at that. This is the first video. Let's go ahead. Okay. So piping inspection code, in-service inspection, rating, repair and alteration. Scope. API 570 covers inspection, rating, repair and alteration procedures for metallic and fiber reinforced plastic piping systems and their associated pressure relieving devices that have been placed in service. You understand this, right? The 570 code is written for in-service piping. It is not intended for a new piping system. Okay, so when the pipe is originally fabricated, API 570 would not be used, but once it goes to service, once maintenance operation starts, then API 570 takes a front seat. This inspection code applies to all hydrocarbon and chemical processes piping covered in 1.2.1 that have been placed in service unless specifically designated as optional services in 1.2.2. So it covers all hydrocarbon and chemical processes except specifically excluded from this code. Okay. This publication does not cover inspection of specialty equipment, including instrumentation, exchanger tubes, and control valve. However, this piping code would be used by owner user in other industries and other services at their discretion. Okay, so this is mainly used for petroleum industries, but other user or other industries can also use this, but it is their discretion. It is not meant for them, but they can use it if they'll feel that this code is going to give them a better results while inspecting it. Okay, the process piping system that have been retired from the service and abandoned in a place that is no longer covered in this in-service inspection code. So once your equipment is abandoned, it is stored at some other location, then the inspection of that abandoned pipe would not be the scope of this code. Okay. However, abandoned in a place piping still need some amount of inspection or risk mitigation to assure that it does not become a process safety hazard because of continuing deterioration. Process piping systems that are temporarily out of service but have been mothballed are still covered by the use by this code. That means you have some abandoned piping system that you are intending to use further in your application, that is covered by this code. But if the pipe is abandoned and you don't have any intention of using it further, then it is not covered by this code. Obviously, you have to keep checking that so that you can understand the damage whatever is happening is as per the requirement or not. If the deterioration that is happening is as per the requirement or not. If yes, then obviously you cannot use this in the further service if the deterioration is more than what you have expected. If the deterioration is less than what is expected, then probably you might re-rate it and you might use it for some other services. Okay. Intent of this code. The intent of this code is to specify the in-service inspection and condition monitoring program as well as repair guidance that is needed to determine and maintain an ongoing integrity of the piping system. That program should provide reasonably accurate and timely assessment to determine if any changes in the condition of the piping would be possibly compromise this continued safe operation. So we need to make sure that in-service inspection and condition monitoring will make sure that whatever piping system that you have, it is safe for service, its integrity is not been hampered or compromised, and the pipe, if any irregularity happens or if anything that happens, it can be repaired as per the criteria of this code so that there is no accidents or leakage that happens in the future. It is also intent of this code that owner user shall respond to any inspection result that require corrective actions to assure the continued integrity of the piping consistent with the risk analysis. So generally what happens is, generally you have a different inspection team or a shutdown team that comes in or a repair organization that comes in, and the pipe is owned or used by some other industry. So a repair organization is different and the pipe that is used or who owns the pipe is someone else. So when the repair organization comes, they would run their analysis and they would give some recommendation of the repair. To act on these recommendations of the repair is the duty of the owner or the user of that piping system. Okay. So it is the intent of this code that user owner shall be responsible to any inspection result that require corrective action to assure the continued integrity of the piping consistent with the appropriate risk analysis. API 570 is intended for the use by the organization that maintain or have access to an authorized inspection agency, a repair organization, and a technically qualified piping engineer, inspector, and examiners, all as defined in. So the organization shall have access to or shall have on their payroll. So they might be contracting these workers or they might have these workers on their payroll. So the workers include the authorized inspection agency. You can have a repair organization that is coming in. You can have technically qualified piping engineers, inspectors that are going to inspect your piping system, and the examiners who are going to perform your NDT. Okay, the definition of all of these are given below. Okay, limitation. API 570 shall not be used as a substitute for original construction requirement governing a piping system before it is placed in service, nor it shall be used in conflict with any prevailing regulatory requirements. That means it is not the intent of this code that this code should be used for original construction. You cannot use this for original construction. You can only use this for the pipe that is placed in service. Again, you cannot use this code if this code is in direct conflict with the regulatory requirements that you should follow. Depending on which regulation or depending on which country you are working with or which local regulations you are working with. So if the local regulation and the API 570 code are in conflict, then the regulatory requirement should be followed. Okay, provided that the regulatory requirement is much more stricter. Okay, if the requirement of this code is more stringent than the regulatory requirement, the requirement of this code shall govern. So if the regulatory requirements are much more lenient than whatever is written in API 570, then API 570 is going to be the guiding code. Okay, but if the regulatory requirement is more stringent and code is more lenient, then regulatory requirement has to be followed, or you'll be out of compliance and will be subjected to fines and all sorts of things. Okay. Limitations we have seen. Specific application. The term non-metallics has a broad definition, but in this code refers to fiber reinforced plastic groups encompassed by generic acronym FRP and GRP, that is glass reinforced plastics. The extruded, generally homogeneous non-plastics such as high density and low density polyethylene are not specifically covered by this code. So we can refer API 574 MTI 129 for guidance on degradation and special issues associated with FRP. So this code is only also good for FRP and GRP, but this code is not good for other high density and high and low density polyethylene, which is not covered by this code. Okay, so it is also good for FRP and metallic pipings. Included fluid service. So which fluid services are included for this code? So except as specified in 1.2.2, API 570 applies to system for process fluids, hydrocarbon and similar flammable or toxic fluid services such as following: raw, intermediate and finished petroleum and chemical products, catalyst line, hydrogen, natural gas, fuel gas and flare systems, sour water and hazardous waste streams, hazardous fluid services, cryogenic services such as any liquefied gas, so basically liquefied nitrogen, hydrogen, oxygen and air, high pressure gases which has a pressure greater than 150 psi in a gaseous stream such as helium, hydrogen, oxygen, nitrogen. All of these are included in the fluid services as per the requirements of API 570. So any pipe that carries these are in compliance with API 570. Optional services are optional. You can use API 570 there, or you might not use it also. Okay. The fluid services are classes of the piping system listed below and are optional with regard to the requirement of API 570. Hazardous fluid services below the designated threshold limits as defined by the jurisdictional requirements. Water, steam, steam condensate, boiler feed water and ASME B31.3 category D services are also an optional service. You can do inspection of those as per API 570, you might not do as well. Okay. Other classes of piping that are exempted from the applicable process piping code. So any services that are exempted by the process piping code itself, that is the construction code, then you can use API 570, you might not use API 570. It is the discretion of the owner or user who is working with that piping system. Okay. Now, fitness for service and risk-based inspection. Now, generally, there are two approaches that we take when we are inspecting any kind of a piping system. Those two are going to be fitness for service. In simple terms, if the part is fit for service, if the part is good for the application it is intended for, if it is going to go up till the next inspection cycle without having any kind of a damage or without having any kind of a catastrophic leak, then we consider it to be accepted up till the next inspection cycle, and we'll see at the next inspection what is the condition now. Okay, so this approach where if the part is good for service, then we are accepting it at service. So this approach is known as fitness for service approach. Another approach is going to be the risk-based inspection approach. In risk-based inspection approach, the approach is generally defined on two basic parameters. First parameter is going to be the probability of assessment and other is going to be the consequence assessment. Probability assessment means that what is the likelihood of your piping failure happening. If the likelihood is very high, then obviously more inspection is needed. If the likelihood of failure is very less, then there is no point in doing extensive amount of inspection, because understand one thing, any inspection that you will do, it will cost you money. Okay, so it is generally a good practice that we should do the least amount of inspection where you get the highest amount of results, but the inspection should not be as less that you are not finding anything. Okay, so it's a delicate balancing act where how much inspection is to be done and is it telling you the required things. Okay, so this approach is known as risk-based approach. So risk-based approach has two major factors. First is probability, how probable your failure is going to happen. Second is consequence assessment. Consequence assessment means that once the leakage happen or once the loss of containment happens, what is the consequences of that? Let's imagine if I have a water going on in a piping system, and if that water leaks, not a major thing is going to happen. Okay, it is not going to be an environmental emergency, it is not going to be a toxic service, personal would not be harmed by it, so not a big deal, right? So the consequence is not that much. Probability can be high, but consequence is not that much. But if the same piping is carrying a concentrated acid, now it can be a big problem if it leaks. If it leaks, it can be a environmental emergency, it can be problems that whatever personnel are available at the location, they might burn or they might have some toxic exposures to it. So now if the leakage happens, the consequences is high, it is known as consequence assessment. Both of these parameters are considered in risk-based approach. Okay, so depending on which approach you are working with, but both of these approaches are recognized by API 570. This inspection code recognizes fitness for service concepts for evaluating in-service damage of pressure containing piping components. So API 570 recognizes fitness for service approach. API 579-1 and ASME FFS1, that is fitness for service, provides the detailed assessment or detailed FFS assessment procedure for specific type of damage that are referenced in code. So now the main question would again lie that okay, we might be able to do FFS assessment, but how do we understand and how do we find that what should be the approaches taken while doing the FFS assessment? For that, the API 570 tells us that whatever FFS assessment you do should be done as per the requirements given in API 579-1 / ASME FFS-1. So whatever fitness for service approach you are going to take, it should be in compliance of that. Okay. This inspection code also recognized RBI, that is risk-based inspection concept, for determining the inspection intervals or due dates and strategies. So API 580, so whatever risk-based inspection approach you are going to take, it is laid down in API 580. Okay, so any risk-based assessment that you are doing has to be as per the requirements of API 580. 580 provides the minimum and the recommended elements for developing, implementing and maintaining a risk-based inspection program for fixed equipment, including piping. API 581 provides the set of methodologies for assessing both probability of failure and consequences of failure for developing the inspection plan. So either of these approaches can be taken, okay, to assess the condition of a piping that you are inspecting. Next, section 2 is normative references. So these are normative references. References are basically codes and standards and documents this API 570 code has used to make this. Okay, so there are many things here. API 571 is damage mechanism. API 572 is inspection practices for pressure vessels. You don't need to remember all of these things, but okay, you need to understand what documents we are talking about here. Okay, 576 is for inspection of pressure relieving devices. 577 is for welding. 578 is for material verification program. 579-1 ASME FFS is for fitness for service. 580 is for risk-based inspection. 583 is for corrosion under insulation. 584 is for integrity operating windows. 598 is for valve inspection and testings. 2201 is for hot tapping practices. B16.34 is valves, flange, threaded and welded end. B31.3 is process piping. PCC2 is repair of pressure equipment and piping. All of these things are used and referenced throughout this code. Okay, you don't need to remember all of these things. Yes, but some of the documents you have already seen that these documents were already present in the body of knowledge. Okay, so don't need to remember each and every name, but you just need to understand that this document is made by referencing some other documents. Next is terms, definition, acronym and abbreviations. So again, it is recommended that you read all the definitions present here. Most of the definitions are very common to understand, but some definitions are more important than others. Okay, So obviously we'll just read it again, but you'll need to understand, you also need to read it, and you also need to understand what is abandoned service, what is an authorized inspector, what is an examiner, and all of these things. What is an owner or a user, who is a repair organization. You'll need to understand these things, and obviously whenever the question arises, you need to understand and you need to identify the definition out of the options that are given in the examination. So abandoned in place, piping system, circuit or contiguous section thereof meeting all the following has been decommissioned, no intention of using in the future, has been completely de-inventoried, purged of hydrocarbon, chemical and physically disconnected from all the energy sources and other equipment and piping systems. We already know what is an alloy, okay? Alteration. This is very important here. So what does an alteration means? Alteration means that you are changing some physical parameters of your component in service. That means your piping was not or the piping when it was constructed, it was something different. Now you want to make some changes to it. Let's imagine if you want to have a nozzle attached to it. Let's imagine if you want to add some cladding attached to it. So all of these are going to be alteration which are going to change the intended service of a piping system. Okay, so this is considered to be an alteration here. A physical change in any component that has design implications affecting the pressure containing capability or flexibility of the piping system beyond the scope of its original design. The following are not considered an alteration: comparable or duplicate replacements and replacements in any kind. Okay, so if you are replacing some damaged items, then it is not considered an alteration. But if you are installing some other item which is going to change the pressure rating of a component, then it is going to be considered as an alteration. Applicable code is the original code that the system is designed with. Okay, in most cases it is going to be SMA B31.3. Authorization, approval for any activity that is done. Authorized inspection agency, now you need to understand that as well. So authorized inspection agency defined as the following: the inspection organization of a jurisdiction in which the piping is used. Sometimes you can have a government organization checking or inspecting some kind of piping system, so that is also going to be considered as an authorized inspection agency. Or you can have an inspection organization of an insurance company that is licensed or registered to write insurance for a piping system. So if you have a piping system, obviously you will have an insurance for it. So insurance company is also going to come and inspect your piping system. That can also be considered as an authorized inspection agency. Third, an owner or user of a piping system who maintains an inspection organization for the activities relating to his equipment and not for piping systems intended for sale or resale. Okay, so an owner has an own organization that is going to run the inspection activities. That would also be considered as an authorized inspection agency. And independent organization. So if the owner does not have it, have workers, or if he doesn't have any inspection organization within his organization, then he might hire some third party, or he might hire some other organization for doing the inspection and repair activities. So that is the inspection activities. It is then these other organization is also going to be considered as an authorized inspection agency. So an independent inspection organization employed or by under contract to the owner user of the piping system that are used by the owner and user, and it is not intended for a sale or a resale purpose. That's simple example of this is shutdown projects. So if you have a shutdown in a company and if you are calling another company to bring their shutdown employees, then that other company which you are going to hire for your inspection are going to be an authorized inspection agency at point 4. Okay, an independent inspection organization licensed or recognized by the jurisdiction in which the piping is used and employed or by under the contract with the owner or user. Okay, so all of these 5 points, either of the point is qualified, then this organization will be considered as an authorized inspection agency. Next is an authorized piping inspector. Who is an authorized piping inspector? In simple terms, an inspector who has APA 570 certificate is going to be an authorized piping inspector. Okay, so an employee of an owner user organization or an employee of the authorized inspection agency who is qualified and certified by the examination under the provision of section 4 annex A is able to perform the function specified in API 570, where contracted or directed to do so. An NDE examiner does not require to be an authorized piping inspector. Wherever the term inspector is used, it terms to the authorized piping inspector. Okay, a person who has API 570 certificate, working for the owner itself or working for an authorized inspection agency. Auxiliary piping, instrument machinery piping, typically small bore secondary process piping that can be isolated from primary piping systems but is not normally isolated. Normally not isolated. Examples include flush lines, seal oil lines, analyzer lines, balance lines, buffer gas lines, vents, drains, etc. The next thing that we have to understand is a CML. CML is also known as condition monitoring location. Condition monitoring location, a specific location in a piping circuit where generally the inspection happens. Okay, so whenever we are going to do the inspection, there is a high chance that we are not able to check 100% of the component. The reason for this is generally going to be the cost. Okay, because if we check 100% of the component, we'll require workers for extended amount of times and we'll have to pay them more as well. So what we'll do is we'll generally make some areas as condition monitoring location. So whenever the inspection is carried out, the inspection will be taking place at the condition monitoring location. If everything is fine at that condition monitoring location, then we can generally assume that everything in this fine in the piping system itself. But if some unexpected thing is happening at the condition monitoring location, then a further investigation might be required. Okay, so CMLs, designated areas on a piping system where periodic examination are conducted. In order to assess the condition of the piping, CML may contain one or more examination points and utilize multiple inspection techniques that are based on the predicted damage mechanism. CML can be a single small area on a piping system. Example, a 2-inch diameter spot or a plane through the section of the pipe where the examination points exist in all 4 quadrants of a plane. Okay. Construction code is the original construction code of the piping system. Corrosion allowance. A corrosion allowance, we already know what this is, but let's understand once again. Corrosion allowance is the extra or additional thickness that is given to a component so that whenever corrosion happens, your system would not be unusable. Okay, so let's imagine I have a condition where the pressure requirement requires the pipe thickness to be 20 mm. So I can make a pipe of 20 mm, but if the corrosion happens and if it goes below 20, then it is unusable because 20 mm is the minimum thickness that is required to sustain the pressure inside the pipe. So what I can do is I can make the pipe not of 20 mm, but I can make a pipe of 30 mm. So 10 mm extra. This extra 10 mm will act as a corrosion allowance. So whenever corrosion happens, obviously the thickness is going to go down, but it will not be in the unusable realm. Okay. Next is corrosion barriers. The corrosion allowance for FRP equipment typically composed of inner surfaces and interior layer which are specified as necessary to provide the best overall resistance to chemical attack. Corrosion rate is the rate of corrosion that is happening. Okay, the rate of metal loss that is happening. This can generally be termed per year and it can be generally in microns per year or mils per year. Corrosion specialist is a person who is very involved in the corrosion of a system. Generally a person might need to be considered if there is very unexpected amount of corrosion is happening. Corrosion specialist, a person acceptable to the owner user who is knowledgeable and experienced in the specific process chemistries, degradation, mechanisms, material selection, corrosion mitigation methods, corrosion monitoring techniques and their impact on a piping system. Corrosion under insulation. So if you have any insulation installed in your piping system, the insulation can be installed for n number of reasons. The simplest reason is to provide heat transfer. To limit heat transfer, we can have insulation on a piping system. But if I install an insulation on a piping system, I would not see if there is any corrosion happening or not because the exterior surface of the pipe is not visible to an inspector while doing visual examination. So the corrosion that is happening beneath the insulation layer is considered to be corrosion under insulation. Okay. External corrosion of a carbon steel, low alloy steel piping resulting from a water trapped under insulation. External chloride stress corrosion cracking of the austenitic and duplex stainless steel under insulation is also classified as CUI damage. Okay. Next is damage mechanism. Damage mechanism is basically what is the specific damage that is happening. It can be a damage due to atmosphere. It can be damage due to the liquid that is flowing inside the pipe. It can be a damage due to process conditions. Okay, so different kinds of damage. All of the type of damage that is experienced by the fixed equipment in the refinery operation is listed down in API 571. So if we want to see any kind of a damage mechanism, if we want to see what are some factors associated with or how to mitigate it or how to inspect it, we'll generally have to refer API 571, which is specifically for damage mechanism. Okay. Any type of deterioration encountered in the refinery or chemical process industry that can result in metal loss, flaws, defects that can affect the integrity of the piping system, corrosion, cracking, erosion, dent, and other mechanical, physical, or chemical impacts. See API 571 for comprehensive list and description of damage mechanism that may affect the process piping systems in refinery, petrochemical, and chemical process industries. Dead legs. Dead legs are basically areas where the flow is stagnant. Okay, so components of a piping system that normally have little to no significant flow. Some examples include blind branches, lines with normally closed block valves, line with one end blanked, pressurized dummy support legs, stagnant control valve bypassing piping, spare pump piping, level girdles, pressure relieving devices, inlet and outlet. All of these things are considered to be dead leg. There is no significant flow there, or you have a stagnant flow there. Okay. Defect. Defect is an imperfection that exceeds the tolerable amount and it is going to be unacceptable. Okay, it is not going to be accepted because this is going to hamper the service life of the component. If it's unacceptable, see, not all discontinuities are defect, but if a discontinuity is greater than the tolerable value, then it can be considered as a defect, and defect is generally not acceptable. Okay, deferral. Deferral is if you postpone something, it is considered to be a deferral. So approved and a documented postponement of an inspection, test, or examination will be considered as a deferral. Okay. Next is due date. Due date is the date at which the inspection should be done. Okay. If the due date is passed, it is considered to be deferred. Okay. So generally deferral is not allowed, but if the deferral is documented, then in some cases it can be allowed. Okay. Examination point. Examination point is the point where you are going to run your examination. Examinations, the act of performing any type of NDT for a purpose of data collection and or quality control functions performed by the examiners. But who is an examiner? So examiner is a person who is qualified to do non-destructive examination. Okay. So an NDT technician in API 570 is considered to be an examiner. Okay. They cannot be called as an inspector because inspector is referring to the authorized piping inspector, not the NDT inspector. Okay. The examiner is a person who assists the inspector by performing specific non-destructive examination on a piping system components and evaluates to applicable acceptance criteria where qualified to do so. But it does not evaluate the results of those examination in accordance with API 570 requirements unless specifically trained and authorized to do so by the owner or user. Okay. Next, we already know what is fitness for service assessment. We have talked about it in great detail in the section 1. Flaw. Flaw is an imperfection that is usually detected by an NDT. It may or may not be a defect depending on the applied acceptance criteria. So a flaw can be considered as a discontinuity. Okay. General corrosion. General corrosion is a uniform corrosion that is happening on the entire system. Hold point. Hold point is a point beyond which the work cannot proceed until the hold point has been witnessed and initiated by the owner or the inspector. So hold point is a point beyond which the work cannot proceed if the hold point is not witnessed by the owner or inspector or whoever is responsible. Indication is the response or evidence resulting from the application of non-destructive evaluation techniques. Inspection point, again the point where you can do the inspection. Injection point. Injection point is something, let's imagine you have a stream of piping, and if you want to, let's imagine you have water and you want to inject something that will lower down the surface tension of this water. So you can inject soap into it. Okay. but water is flowing and you are injecting soap, this injection point where the soap is going to enter the stream will be considered as the injection point. Okay, so injection points are location where water, steam, chemicals or process additives are introduced into the process stream and are relatively low flow volume rates and are compared to the flow volume rate of the parent stream. Okay. In service, obviously we know what an in service means. In service means once the part is placed into the service. Okay, a piping system not currently in operation due to the process outlet, it's still considered to be in service. Inspection plan is the plan how you are going to run your inspection. A documented set of actions and strategies detailing the scope, extent, method and timing of the specific inspection activities in order to determine the condition of the piping system circuit based on their defined and expected damage. Integrity operating windows. Integrity operating windows are basically, let's imagine, if I have a piping system and it is mentioned in the documents that this piping system should not go beyond 17 degrees Celsius at the lower temperature range and above 200 degrees Celsius at the higher temperature range. Okay, so the pipe should be maintained at 17 degrees Celsius to 200 degrees Celsius. This is what it was designed for. Okay, but if there is any unforeseeable condition where it goes beyond 200 at the upper shelf value or lower than 17 degrees Celsius at the lower shelf, whenever this crosses this threshold, we would consider this to be integrity operating window as exceedance, and the value between 17 to 200 will be considered as the integrity operating window. This is the window where your system should work. If it goes beyond that, then your integrity operating window has been breached. Okay, the same thing can be done with pressure. Let's imagine if I have a pipe that can sustain a pressure at the lower end 30 psi, at the higher end 200 psi. So 30 to 200 psi would be considered as an integrity operating window. Okay, the established limits for the process variables that can affect integrity of the equipment if the process operation deviates from the established limits for predetermined amount of time. Intermittent service, condition of a piping system whereby it is not continuous in operation, that is, it operates at the regular or irregular intervals rather than continuous. Lining, a non-metallic lining or a metallic lining installed in the interior of the pipe whose properties are best suited to resist damage from the process than the substrate material. Okay. Localized corrosion is a corrosion in a very smaller area. Sometimes it is also considered to be a pitting corrosion. So deterioration restricted to the isolated regions of the piping system, that is corrosion that is confined to a limited area of a metal surface. Okay. Major repairs. Major repairs are repairs which are done on a piping system which might require a hydro test. Okay. So welding repairs that involves removal and replacement of a large section of a piping system is considered to be a major repair. Okay. Management of change. So if any change is happening in your organization or if in your industry, then how that change is managed is management of change. Okay. A document management system for review approval of changes, both physical and process changes, to piping systems prior to the implementation of the change. Material verification program is verification of the material that you have bought for repair or for alteration. So material verification program, you can do destructive test, non-destructive test, positive material identification to identify the composition of the material. All of these will be considered as a material verification program, and we have a different code for this, API 578. Maximum allowable working pressure. Maximum allowable working pressure is the maximum amount of pressure that your part can sustain, or it's the maximum amount of working pressure that your part should sustain during the working condition. Okay, so maximum internal pressure permitted in the piping system for continued operation at most severe condition of the code, coincident internal and external pressure and the temperature expected during its service. It is the same as design pressure as defined by ASME B31.3. So ASME B31.3 will consider design pressure. API 570 will call the same design pressure as maximum allowable working pressure. Both are same. It's subjected to same rules related to allowance for variation of the pressure and temperature both. Minimum alert thickness, flag thickness. So we can say that if the thickness goes below this, then it is going to alert us. That is minimum alert thickness. MDMT is the minimum design metal temperature. It's the lowest threshold value that your part should work at the temperature range. So again, the same example I'm giving. If the pipe is to be working between 17 degrees Celsius to 200 degrees Celsius, then 17 degrees Celsius is going to be considered as the minimum design metal temperature. Okay, if it goes below that, then some additional things need to be done. Okay, minimum required thickness, again the minimum required thickness to sustain the pressure in your equipment. Mixing point where two flows are mixing. Non-conformance is generally a condition which is not acceptable, okay, as per code, standard, specification or something else. Okay, offsite piping, piping system not included within the plot boundary limits of a process unit such as hydrocracker, ethylene cracker or a crude unit. On-site piping is the piping installed in the site simply. Owner user, the organization that exercises control over operation, engineering, inspection, repair, alteration, pressure testing and rating of the piping system will be considered as the owner or user of that piping system. Okay. Piping circuit. So piping circuit is a very technical concept when you think about it. So piping circuit is basically, organization might have large number of pipes. Okay, it might have 6,000-7,000 pipes. Not all of them can be assessed singly. 5,000 and 6,000 pipes, obviously we can inspect them, but it is going to be cost restrictive. So what we are going to do is, we are going to classify the pipes based on the same operating conditions, same material from which they are made, and generally they will be subjected to same kind of damage. Okay, so this classification will be considered as a piping circuitization. So a subsection of a piping system that includes piping and component that is exposed to process environments of a similar corrosivity and expected damage mechanism and is of similar design condition and construction material, whereby expected type and the rate of damage can reasonably be expected to be same. Okay, so if everything is same, then we can assume that the damage conditions would also be same. Okay, that will be piping circuitization. Piping engineer is basically the engineer of the owner, user, okay, who will lay down all the technical aspects of your piping system. Okay, so it is going to be generally an owner's inspector or owner's engineer who will run the day-to-day operation of your piping. So he might do stress analysis for the piping. He might need to be consulted while doing major alteration, major repairs. Okay, so one or more person of the organization acceptable to owner, user, who are knowledgeable and experienced in engineering disciplines associated with the evaluating mechanical and material characteristics affecting the integrity and reliability of the piping components and system. A piping engineer, by consulting with the appropriate specialist, should be regarded as the composite of all entities necessary for properly addressing the piping design requirements. He's not an inspector, he's an engineer. Okay, inspector will inspect and he might give some recommendation, but engineer generally will check that all of these requirements are as per the requirements of the engineering analysis or not. Okay, piping system as an assembly of the interconnected pipe that is typically are subject to the same process fluid composition and other design conditions. Post-weld heat treatment is the heat treatment or stress relieving that is done after the welding operation. Generally it is done to release hydrogen induced cracking and to make sure that the grain structure in the heat affected zone return back to the original condition, or it is generally going to be more ductile, because if you don't do post-weld heat treatment in medium to high carbon steels, then it is subjected to brittle fracture. The area around the heat affected zone becomes brittle because of the heat that is given during the welding operation. Minimum design thickness, again the minimum thickness that is required to sustain the pressure. Primary process piping, the process piping in normal active service that cannot be valved off, or if it were valved off would significantly affect the unit operability. Process piping, hydrocarbon or chemical piping located or associated with the refinery or manufacturing facility. Process piping includes pipe rack, tank farm, process piping unit, but excludes utility piping. Quality assurance, all planned systematic preventive actions required to determine if the material, equipment or services will meet the specified requirements so that the piping will perform satisfactorily in service. Quality assurance plan will specify the necessary quality control activities and examination. So quality assurance is generally a reactive action. Sorry. Uh, Quality assurance is generally going to be a preventive action. It is going to lay down all the requirements that are needed. Quality control is going to be a reactive action where once everything is done, you'll check if it was as per the requirements that were laid down before in quality assurance plan. So quality control, whose physical activities that are conducted to check the performance with the specification in accordance with the quality assurance plan. Non-destructive techniques, hold point inspections, material verification, checking the certification documents, etc. Renewal, activity that discards an existing component, fitting or other portion of the pipe circuits and replaces with a new or existing spare material of same or better qualities as the original piping components. Repair, work necessary to restore the pipe to condition suitable for safe operation. Repair organization, any of the following is considered to be a repair organization. Owner, user of the piping system who repairs and alter his or her own equipment in accordance with API 570. Okay. A contractor whose qualifications are acceptable to the owner or user of the piping system and who makes repairs and alteration in accordance with 570. That means an owner can hire a different organization to do the repair activities. Okay. It should be the owner should accept the other organization. That means owner is going to hire themselves. Okay. The organization that is authorized by or acceptable and otherwise not prohibited by the organization, by the jurisdiction and who makes the repairs in accordance with 570. Okay. Any of this is considered to be a repair organization. Rating is changing the condition of a piping system. That means let's imagine if I have a pipe that has a maximum allowable working pressure of 200 psi. Now due to some reason I feel that it should not go up to 200 psi because let's imagine corrosion has happened. Now I feel that it will not sustain 200 psi. It might sustain 150 psi. So I can change the rating of the pressure to 150 psi from the original 200. This is considered to be re-rating. The work process of making calculation to establish pressures and temperature appropriate for the piping system, including design pressure, temperature, structural minimums, required thickness, etc. So that is re-rating. Re-rating is change in design metal temperature, design pressure or maximum allowable working pressure of the piping system, sometimes called as rating or re-rating. Okay. Risk-based inspection, we already know this. Risk-based inspection is the inspection based on the consequences of failure and probability of failure. Okay. The risk-based inspection has to be approved or it has to be conducted by the owner or user himself. Okay. So owner might bring out another organization to do RBI, but that RBI assessment has to be approved by the owner. You cannot apply that RBI without consulting the owner. Okay. So risk assessment or risk management process that were focused on inspection planning of the piping system for the loss of containment in the processing facilities, which considers both probability of failure and consequence of failure due to materials of construction and deterioration. Secondary process piping, the process piping located downstream of a block valve that can be valved off without significantly affecting the process unit operability is commonly referred as secondary process piping. Often secondary process piping are generally small bore piping, SBP. Small bore piping are piping which has a size less than NPS 2. Salt to air interface, the area where external corrosion may occur or be accelerated on a partially buried pipe or buried near where it ingresses from the soil. Structural minimums, the minimum thickness without corrosion allowance based on the mechanical loads other than pressure that are result in longitudinal stress. Temporary repairs made to the piping system in order to restore the sufficient integrity for continued safe operation until a permanent repair can be scheduled and accomplished within the time period acceptable to the inspector or the piping engineer. Utility piping, non-process piping associated with the process unit, that is steam, air, water, nitrogen, etc. Utility piping is not under the scope of API 570. Now these are acronyms that are used throughout this code. You just need to understand what these acronyms are, that's it. Okay. Now, in the next video, we'll go to owner and inspection organization's requirement and what they need to follow. Okay. So, and this video will end here. From the next video, we'll start owner and user inspection organization.